Right, so that's the start of chapter 5.1, 2 types of random variables. That's what chapter 5 is all about, random variables, and we're going to learn about those 2 types in this section. So first of all, what is a random variable? Well, a random variable takes on numerical values that describe the outcomes of a chance process. Numerical values that describe the outcomes of a chance process. So again, it involves probability, right? Chance process, but again, it's numerical, okay? Quantitative, numerical. So the probability distribution of a random variable gives the possible values and the corresponding probabilities. It gives the possible values and the probabilities that of those values happening. So that's what the top row is. It'll be all the values of your random variable. Okay. And then the bottom is the probabilities associated with each of those outcomes. Okay. Now, note, in a valid probability distribution, the probability is P sub I, which is just the general probability notation, must satisfy 2 requirements. Number 1, every probability is a number between 0 and 1. I guess I should put between 0 and 1, right? And remember, that's also percentages between 0 and 100%, right? So be aware of that. And then number 2, the sum must be 1. Again, if you add up all the probabilities, you should get 1 because it has to include all of the possibilities. So the first type of random variable is called a discrete random variable. And notice it has this variable letter x. So whenever you're talking about a random variable, typically they give a capital letter variable as the random variable. So in a discrete random variable, you have a fixed set of possible values with gaps between. Not every value on a number line can be a result if you're dealing with a discrete random variable. So the probability distribution of a discrete random variable does list the values with the corresponding probabilities. Okay. All right. Okay, example 1 here. How can we quickly assess baby's health at birth? In 1952, Dr. Virginia Apgar suggested 5 criteria for measuring a baby's health at birth: skin color, heart rate, muscle tone, breathing, and response when stimulated. She developed a 0-1-2 scale to rate a newborn on each of 5 criteria. A baby's Apgar score is the sum of the ratings on each of the 5 scales, which gives a whole number value from 1 to 10. So this means you can't have a score of 5.9. You can't have a score of 7.3. You have to have a score of 0, 1, 2, 3. That is the very definition of a discrete random variable. Fixed values with gaps. So keep in mind this is a discrete random variable. Apgar scores are still used today to evaluate health of newborns. Although this procedure was later named for Dr. Apgar, the acronym Apgar also represents the 5 scales: appearance, pulse, grimace, activity, and respiration. And again, I can vouch during my children's births, they do take the babies and do this real fast. And I think they even do it in the aftercare room as well. So what Apgar scores are typical? To find out, the research recorded the Apgar scores of more than 2 million newborn babies in a single year. Imagine selecting one of these newborns at random. That's our chance process. So again, you're always going to see random selection involved. To find the random variable x equals the Apgar score of a randomly selected baby 1 minute after birth. There we go. There's your x. The table gives the probability distribution of x. Show that the probability distribution for x is valid. Okay, 2 things. Number 1, look at all of your probabilities. Are they numbers between 0 and 1? Yes, they are. Each probability is a number between 0 and 1. Okay, and then number 2, what do they add up to? Well, 0.001 plus 0.006 plus ... don't waste your time, plus 0.053 is going to equal, and I'm going to pause it while I do this real fast just to verify. And yes, they did come out to 1. So your 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 probabilities had a sum of 1. And that makes this a valid probability distribution.